Fitz's law is a descriptive model of human movement primarily used in human-computer interaction and ergonomics. This scientific law predicts that the time required to rapidly move to a target area is a function of the ratio between the distance to the target and the width of the target. Fitz's law is used to model the act of pointing either by physically touching an object with a hand or finger, or virtually, by pointing to an object on a computer monitor using a pointing device. Fitz's law has been shown to apply under a variety of conditions, with many different limbs, manipulanda, physical environments, and user populations. Original model formulation. The original 1954 paper by Paul Fitz proposed a metric to quantify the difficulty of a target selection task. The metric was based on an information analogy, where the distance to the target is like a signal and the tolerance or width of the target is like noise. The metric is Fitz's index of difficulty. Fitz also proposed an index of performance as a measure of human performance. The metric combines a task's index of difficulty with the movement time in selecting the target. In Fitz's words, the average rate of information generated by a series of movements is the average information per movement divided by the time per movement. Thus, today, IP is more commonly called throughput. It is also common to include an adjustment for accuracy in the calculation. Researchers after Fitz began the practice of building linear regression equations and examining the correlation for goodness of fit. The equation expresses the relationship between MT and the D and W task parameters, where MT is the average time to complete the movement. A and B are model parameters. ID is the index of difficulty. D is the distance from the starting point to the center of the target. W is the width of the target measured along the axis of motion. W can also be thought of as the allowed error tolerance in the final position, since the final point of the motion must fall within a plus or minus W2 of the target's center. Since shorter movement times are desirable for a given task, the value of the B parameter can be used as a metric when comparing computer pointing devices against one another. The first human-computer interface application of Fitz's law was by Card, English, and Burr, who used the index of performance, interpreted as 1AB, to compare performance of different input devices, with the mouse coming out on top compared to the joystick or directional movement keys. This early work, according to Stuart Card's biography, was a major factor leading to the mouse's commercial introduction by Xerox. Many experiments testing Fitz's law apply the model to a data set in which either distance or width, but not both, are varied. The model's predictive power deteriorates when both are varied over a significant range. Notice that because the ID term depends only on the ratio of distance to width, the model implies that a target distance and width combination can be rescaled arbitrarily without affecting movement time, which is impossible. Despite its flaws, this form of the model does possess remarkable predictive power across a range of computer interface modalities and motor tasks, and has provided many insights into user interface design principles. Bits per second, model innovations driven by information theory. The formulation of Fitz's index of difficulty most frequently used in the human-computer interaction community is called the Shannon formulation. This form was proposed by Scott McKenzie, professor at York University, and named for its resemblance to the Shannon-Hartley theorem. Using this form of the model, the difficulty of a pointing task was equated to a quantity of information transmitted by performing the task. This was justified by the assertion that pointing reduces to an information processing task. Although no formal mathematical connection was established between Fitz's law and the Shannon-Hartley theorem it was inspired by, the Shannon form of the law has been used extensively, likely due to the appeal of quantifying motor actions using information theory. In 2002 the ISO 9241 was published, providing standards for human-computer interface testing, including the use of the Shannon form of Fitz's law. It has been shown that the information transmitted via serial keystrokes on a keyboard and the information implied by the ID for such a task are not consistent. Adjustment for accuracy, use of the effective target width. An important improvement to Fitz's law was proposed by Crossman in 1956 and used by Fitz in his 1964 paper with Peterson. with the adjustment, target width is replaced by an effective target width. W is computed from the standard deviation in the selection coordinates gathered over a sequence of trials for a particular DW condition. If the selections are logged as x coordinates along the axis of approach to the target, then this yields. And hence, if the selection coordinates are normally distributed, W spans 96% of the distribution. If the observed error rate was 4% in the sequence of trials, then W equals W. If the error rate was greater than 4%, W W, and if the error rate was less than 4%, W.